This channel. Thank you so much for tuning in. The main discussion we want to take on today is the issue concerning the thermochemistry. This is one topic, but it's important to understand. And as per our competence curriculum, the competency for this whole topic says the learner should analyze and evaluate the thermodynamic principles and also the processes. Of course, this word thermodynamic has these two words, that is thermo and then dynamic. The word dynamic in physics normally means change, something that can change. And the word thermo is about heat, so possibly we are talking about changes in heat. Now we are saying that we shall study those changes in heat and all the processes that involve these changes in order to predict what we are calling the spontaneity. We shall see what that means, and the feasibility of the chemical reactions and the chemical processes. So everything we are discussing here is concerning heats, but how these heats are going to react, they're going to affect the chemical reactions and chemical processes. The word spontaneity simply means it talks about how a reaction starts, how a reaction is able to go on. That all encompasses the feasibility involved. It talks about how a reaction is going to go on, how a reaction takes place. So there are reactions that move very fast because of heat supplied, and there are some of them that don't need heat. There are many, I believe, if you think about the food you cook at home, it needs heat for the cooking to take place. If you're doing any freezing, that means heat changes have to happen. Maybe heat has to come from the thing that you're freezing so that that thing can freeze. It has to lose the heat so that it can become cold. You have to think about all those as the heat, the changes in heat, the thermodynamics. Now, we want to move to really understand this. Before you come to the first subtopic, which is enthalpy changes and energy profiles, you need to understand some more thing here. I have this for us. You see, understanding thermochemistry is very important because it allows us to quantify. The word quantify means we can know the amounts. We can get to know the amounts. It is very important. At times we have to calculate the amount of heat needed for a certain process, so to avoid getting burnt products. Also, there is need to predict. At times you have to just predict based on what we've experimented, and then we see what's happening here and there. And then this is very important in very many fields, as you can see here. It's about very many fields. We can use it to predict whether the reaction can go on, what this word means, spontaneous, or it may not even happen. So in simple terms, if we need to define the term thermochemistry, on checking here, the term thermochemistry is just a branch of something called the thermodynamics. And we are saying that thermochemistry will focus on the changes in heat changes, but then these have to be associated with chemical reactions, all with physical transformations. You observe that these are physical changes, those that include melting and boiling. They're not chemical reactions, but they also involve heat. So we have to talk about that as well, that via those physical transformations where states of matter change from one form to another, heat might be involved. And if heat is involved, then we shall study them under this thermochemistry. Men, people have to understand really, if you talk about heat and chemical reactions, how do these things merge? You observe that every time there's a chemical reaction, an issue concerning bonds has to arise. Bonds have to be broken or bonds have to be formed every time there is a chemical reaction. For example, if I'm reacting hydrogen gas plus oxygen gas, you observe they are separate. But if I get them in a chemical reaction, if I get hydrogen, let me call it H2, just very quick here, and I combine it with the O2, that is oxygen gas, you observe that so that reaction between hydrogen and oxygen is now able to form a bond connection. You observe this equation here. there will be a bond connection, because now hydrogen and oxygen were alone each, but now they are forming a bond. And then that means here bonds are being formed. And when you talk about bonds, you're talking about something called chemical energy. The bonds have an energy called chemical energy, and physics doesn't allow us to destroy any energy. So that's why at one point the chemical energy might need to turn into heat energy. That's what happens at times. Chemical energy becomes heat energy, and then vice versa. There are times when this has to become chemical energy. That means, so those can be the changes between the chemical reactions, and then they connect with the heat changes. That's the discussion we shall be always going through. So you're saying that there can be bonds that are being broken, and that means you need energy to break the bonds, and maybe there are times when you have to just form bonds, and you'll have to release heat if you're forming those bonds. Thermochemistry helps us to, we're moving by here, helps us to measure and calculate these energy changes, primarily through the concept known as the enthalpy. It will be our main discussion as we go on, and of course that represents the heat exchanged. When we talk about enthalpy, we are talking about heat changes maintaining and considering a constant temperature. We're discussing A-level chemistry, so we shall have to go into depth of all this. So when you talk about the kinds of thermochemistry, the kinds of heat changes, they are normally two, as we shall go into depth of understanding. That is the exothermic reaction and then the endothermic reaction. The more we discuss this, the more we shall build a better understanding of all this. Of course, the term exo meant outside, which means heat is being released to the outside. That is the surrounding. We shall understand clearly what surrounding means, because at times people end up forging and forgetting what surrounding means in these experiments. Now, endothermic reaction, as the word endo is meaning in, that means heat is being absorbed into. It is absorbed from the surrounding, then coming into the reaction media. So it is coming from the surrounding reaction media, but initially in exothermic, as we shall discuss more, it is being released to the reaction media. We shall give examples more and discuss more about this. But before you go on, I want to talk about the key reasons why it is important to understand this thermochemistry. One of them is here, predicting the reaction and behavior. Predicting the reaction behavior. You know, we have to understand that this reaction need heat or no heat, so that we can know what to do with it. If you know you're going to cook, obviously you know you need heat for you to cook. So you have to provide heat for you to cook. And if you have no heat, of course, there will be no cooking. So you know the behavior of that reaction. Next, we have the energy provision, production, and efficiency. So from thermochemistry, you can know that such a substance, this one or this one, let me just go back here. You can know that a fuel is the one that when burnt produces useful energy. So there are many kinds of fuels, the gasoline, the natural gas, the coal, and these provide energy that can be, of course it was chemical energy, but can become heat energy as we go on using it. So you can clearly identify which substances are fuels by checking their heat change. Do they release heat or produce heat? You know, you've heard of people who are making fuels from animal waste, that is the biogas. So why do we consider it to be a fuel? Because this biogas is able to produce heat when burnt. So you can easily know that this one is a fuel because I've detected it can produce heat when burnt. Then we have the practical and everyday applications. If you need heating, you know you need fire. If you need cooling, you know you need to have ready, not heat included. Cooking, all that, you know it needs heat because heat has to come from somewhere and then it enters into the food to be cooked. The physiology, that is talking about our bodies. Our bodies at times we have to generate heat in order to have chemical reactions. So you know that if I need warmth, then I have to do this and this at my maybe food is broken down. So whenever you eat food, food is broken down, and then you really feel like the warmth has come. That's why many people feel angry in cold days, because in cold days your body has to produce a lot of heat for you. That means food is being broken down. The word metabolism means breaking down of food. So lastly here, environmental science. It is simple and it is clear, understandable that whenever you burn fossil fuels, we can observe that they produce heat, and therefore I can use them as a fuel. So understanding that it can produce heat, that is what we're going to talk about, and then it can help us in environmental science, as you can see, to understand which material produces heat needed, and it also does not pollute the environment so much. So clearly, today it has been just a great introduction. I want us to take time and subscribe to the channel. Don't forget to always like these videos. It will be very important if you like these videos. Very, very powerful. Yeah, let's meet then. Have a nice time.